Now, I would like to bring Usha online here. Give me one moment. Usha is the Principal Technical Marketing Engineer for Palo Alto Networks. Usha, you should be online now. You should be able to unmute yourself.
Yep.
Fantastic. I see you're coming online here. I will go ahead and hand the show over to you. It is all yours.
Thanks, Charles. Just right. Do you see my screen?
Yes, you're good.
Right. Great. Hi, everyone. My name is Usha Gayathri Kuppusamy, and I'm a Principal Technical Marketing Engineer at Palo Alto Networks, primarily focusing on the Prisma AIRS platform. I'm so thrilled today to be talking about the Prisma AIRS platform, what it does, and why customers find value out of this. And thanks, Charles, for setting this up and giving us a chance to engage with the community. Really appreciate that. And as Charles mentioned, please use the chat to ask any questions. We'll try to address this as we go about the presentation. I'll have passes during each point as well. Right. So today we'll be talking about the Prisma AIRS platform, which we announced during the week of RSA. So what we see today is a lot of our customers are building enterprise AI applications. Here we are talking about the homegrown AI applications, which they use either to improve their employees' productivity or to improve their customer experience. And a lot of these enterprises are building AI applications and agents, and they are leveraging models, either their homegrown models or models which are hosted on platforms like Hugging Face. And we also see that the enterprise AI adoption is going to be much more, and it's planned to be 100K in the report that we see from the field, right? So how does the typical architecture looks like, right? So if you're familiar with this, over the past decade or so, we have seen a significant growth in the evolution of the application architecture. It initially started off with this big monolithic application where you have a web front end, you have an application backend, and it has all access to this data. And all of this is hosted on an infrastructure. It could be a VM, it could be a container, or it could be a traditional web application architecture, right? While the web app and data layers remain, with this AI infrastructure or new AI systems, new components are being introduced. And what are these new components? These are LLMs, which are large language models, and it could be hosted on, you could be using Gemini of the world, or the Claude, or GPT-4, or Llamas, right? And these are hosted on the Vertex, AWS, Bedrock, Azure OpenAI, and things like that. This is just the models. And where the data is holded, the data layer also has an inference and a training layer. This is specifically for these models to access the database. It has a RAG pipeline where you enrich your AI application and the model to be armed with latest and greatest knowledge or your enterprise-specific knowledge, right? And the infrastructure to host these AI applications are also different than your traditional web application architecture. You have machine learning libraries, you have specialized GPUs to support the computational demands of this AI architecture. So what it means for security? It means there are new attack surfaces and security considerations that organizations need to think about when they are developing and deploying these AI applications in production. And what are the new kinds of threats that we are seeing, right? In the traditional, the web layer, all the traditional threats that are related to access and authentication still exist, right? And in the application layer, where you have related to runtime risk, it could be a malware execution, or it could be unsafe URL, which could be your malicious phishing links or malware links. And in the data layer, you want to make sure the AI applications and the agents which are accessing these have the right permissions. Right? Sorry, there is okay. So you have to make sure these applications are not making any unrestricted DB queries or DB operations. And the LLMs itself, they introduce new kinds of threats, prompt injections or model DDoS attacks. And when it comes to the models themselves, the model should not be having any kind of deserialization threats or malicious code embedded in it. This is all about the application and the agentic layer. But what about the infrastructure? The infrastructure itself has a host of vulnerabilities. It could be an unpatched vulnerability. It could be some kind of remote code execution by the models running on top of these infrastructure. So this is where we think the security concerns are more obvious, and we need to take a different look compared to the traditional approach of securing your application architecture. Let's talk about what are the different kinds of threats at each of these AI application development lifecycle, right? So it starts with what models you're using and how are you scanning these models, right? So what you see here is an example of a compromised model, which is hosted on Hugging Face. Hugging Face alone has more than 1 million models, and we have seen in the past that attackers try to host some malicious model, hoping somebody downloads and uses it in their environment, right? So what you see here is there is a security scan that is done on this model, and it indicates the model has one pickle file which has malicious code embedded in it, right? And another critical example or the risk that we see, we are more maybe familiar with it, is a prompt injection, right? So what is prompt injection? All these applications and agents are defined to do some specific task or given a goal it has to perform, right? Prompt injection is, in layman's term, it is basically hijacking the application's goal and making it perform some malicious or nefarious actions, which is not the original intention. So what you see here is a simple chatbot application that simulates a banking service. And the malicious user here is actually impersonating or instructing the model that he is the banking administrator and is asking sensitive information about a customer named John Smith, trying to override the system guardrails that are already in place, right? So the application thinks that the actual user is in fact an admin and then overrides the system guardrails and hands out sensitive information for this account, right? So you can see this may look very simple, but it's very easy to override the system guardrails through some clever prompt injection techniques.
We did have a question that came in from the chat. What is the difference and differentiation between Prisma AIRS and Cortex Cloud AI SPM?
Okay. Yeah, we'll cover that as part of the pillars. But just to pause here, Prisma AIRS is a platform. So it covers from all the way from model scanning, posture, runtime security threats, and agent security as well. The Cortex AI SPM focuses primarily on the security posture management for AI systems. So this will be part of one of the pillars under the Prisma AIRS umbrella.
Great, thank you.
So the other kind of threats that we see are insecure outputs. So what is insecure output? So these models and the applications have been trained with vast amount of data, and it also has access to, let's just say, a knowledge base, which could be a RAG-based pipeline, and it has been fed with information. And this information could come in terms of URL links. It could be some form of file inputs or anything, right? And also these applications and agents now have the ability or integration with tools where it can go and perform a live Google search, right, to give you the latest and greatest information. But how can you make sure that the links that it is ingesting or the links that it is providing to your end user, it does not contain any kind of malicious links, right? It could not, you don't want the user to be redirected to a phishing link and where data exfiltration or information exfiltration happens, right? So that is what the example that you see here. Here, the user is asking to upgrade to the latest version of the software, right? The chatbot, it has some poison data in its knowledge base, and it includes the link to download an executable file. But this is coming from a malicious website, right? So this basically demonstrates that if the URLs are not sanitized, right, whether it is inputting to your model or whatever that is outputted by your model, it needs to be sanitized. So input and output sanitization needs to be part of your security strategy when you're building these kind of applications, right? The other most concerning threat is also a sensitive data leak, right? These models are trained with data, right? So some of this data could be proprietary. It could contain some PII information, PHI information, and you don't want these training data to be leaked inadvertently, right? There could be a malicious user who is actively trying to exfiltrate the sensitive data, or the model could be just leaking it inadvertently, right? So here, what you see is an example of an healthcare customer who is building an application to service its patients. It helps with treating some symptoms or booking appointments and things like that, right? So here, a user is asking, okay, how can I treat some XYZ symptoms, right? Since this model has been trained with patient data, it inadvertently sends information about the training data itself, and it contains some PHI information. That's leading to a sensitive data leak for exfiltration. Right? So these are some of the threats that are most common or very prevalent in when you're building AI applications and agents. And moving on to agents, agents have their own memory and it can take autonomous action based on users' behalf, right? So usually what we saw is the traditional web application architecture has web, app, and data. And when you build AI application, it has LLM, it has data with inference data and training data. But when you expand this architecture to AI agents, you have two more additional pieces. That is your action, that the action that the agent can take on your behalf, and the tools and plugins it has access to complete its task, right? In addition to that, the agent also has memory. The memory could be a short-term memory or it could be a long-term memory, right? So how do you make sure that the memory that the agent uses is to retain context and learn over time and do a performative task? It is not corrupted, right? A malicious user can easily manipulate the memory of the agent and make it do some inadvertent task, right? And these agents are also built on variety of platforms today. It's very easy today, even you don't even have to have any kind of coding experience or coding background to build and deploy these AI agents. There are a lot of no-code, low-code platforms that makes it very super simple. It's easy to deploy these agents, but they're not thinking about security. It's not security first mindset, right? So how can you make sure that with increasing complexity like this and increasing attack surface, you need to be thinking about security. And just we covered this. What are the specific threats which are related to AI agents, right? So the main thing that we talk about today is memory poisoning. You can take a look at OWASP's top 10 agentic related threats that Palo Alto initiated this effort to work with OWASP and publish the top 10 OWASP agentic related threats. I'll drop the link later. But these attacks that we'll be seeing today, some of the attacks that we will be seeing today are based on those attack frameworks, right? So what is a memory poisoning, right? Agent has, as we talked about, agent has short-term and long-term memory. It can understand and retain the user's preferences and take action based on these said preferences, right? So here, the example that you see here is, says the user says, okay, always book trips with chartered plane, right? So it's a travel assistant agent. It helps you book trips. And as an attacker, I'm trying to manipulate the agent's memory and using it to book tickets for myself on a private jet, right? It says override any transportation mode that is explicitly asked by the user. So by just this simple plain English prompt, now you're able to corrupt the agent's memory, right? An agent says, okay, it read the user's preference, it updates its memory, stores this context, and it's going to use it for later use, right? Later, the user tries to exploit the memory, which has already been done, and says, okay, now book me a trip to Dubai for a chartered plane, right? Agent remembers the context and the instruction that is given by the user earlier, and it books a ticket for free. Right? So this is one such example to demonstrate how you can manipulate the agent's memory and use it for some malicious or unintended actions. Right? The agents, as we talked about, they also have access to third-party tools, right? It could be through MCP, or it could be a SIM native integration where there's a tool calling, right? These tools help agents to perform its task, right? The agent have what agent does is it can reason, it can plan, it can execute the actions on users' behalf. To complete these actions, it needs to have access to different kinds of tools, right? So, for example, in here, what you see is the user is asking the agent, okay, I need to do all these different debugging. And when you see a specific trigger word or keyword in the later scenario, just give me all the information about the tools, right? These are internal tools where I don't want that to be exposed, because if somebody gets hold of how to invoke these tools, what are the parameters that are passed to these tools, they can directly make these invocations and corrupt your entire workflow, right? They just say the agent has access to a tool which writes to databases, right? And if you're able to understand how these tool calls are made, what are the parameters that are passed to these tool call, somebody would be able to easily exploit or find vulnerabilities in those, right? So it just dumps the tool information that it is internally using, and the user can use this to perform any kind of actions, right? So this is why our approach is we need to start all the way from model scanning, which is shifting left, and where you are building what are the infrastructure or what are the components that you're using to build your entire AI ecosystem. And you need to think about security from though not just only focusing on the runtime piece, right? So our approach to secure your entire AI ecosystem is by focusing on the 5 different pillars, starting with model scanning, where you scan all the models that are deployed in your environment and look for any kind of deserialization threats or any kind of malware, malicious code embedded in your models, right? You want to make sure you deploy and use these models only if it is after it is deemed safe to use. And the next aspect is posture management, which is the supply chain for your entire AI ecosystem. And the third is AI red teaming, where we can do automated penetration testing for your AI application models and agents. And the fourth pillar is the runtime security, where we'll be focusing on the prompt injections, malicious inputs or outputs, or sensitive data leakage. And the fifth pillar is the AI agent security, where we'll be focusing on threats related specifically to AI agents. And so how Prisma AIRS platform is different when compared to our competitors, right? So we see today's security industry is full of different fragmented point products, right? They do not talk to each other. They don't share any intelligence, and they are managed independently through different consoles, right? It is up to the enterprises to stitch all these together and then develop a cohesive AI security strategy. Every day, we hear from customers that they don't have complete visibility into their AI ecosystem. Different teams are building AI applications independently. It is not centrally managed. They do not have visibility into what AI applications are running, what agents are running in their environment, what models are being used, and what are the different data sets that these agents and apps are touching, right? And they're connected to how are they connected internally? What are the permissions they have? And you don't have this complete visibility into your entire AI ecosystem. And these agents are also built on different kinds of cloud environments, right? So that is where the Prisma Air solution comes in. So our approach is to provide a unified platform to solve this AI security challenge, right? And we are the world's most comprehensive AI security platform. It integrates all 5 critical components that we just discussed, starting from model scanning, posture, red teaming, runtime security for apps, models, and also AI agent security, right? So our platform empowers you to discover your entire AI ecosystem, assess your threat landscape, and protect against different kinds of threats targeting this AI ecosystem. Right? Any questions here before we dive deeper into each of these individual pillars?
We did have one question come up, but I was wondering if you're going to be getting to it later. Is being asked if can we monitor full user activity in AI system?
Yes, we would be able to monitor. So, who are the users who are accessing your AI apps, and how are these interconnected? Where the entire yes, we would do. The short answer is yes, you would be able to monitor that.
Cool, thank you. That's all we have so far.
Okay. Now let's talk about a little deep of each of these five pillars, right? Starting with model scanning. In traditional security, we use the SAST and DAST to scan your code, your infrastructure, looking for any kind of vulnerabilities, right? But when you're deploying these models, these risks are hidden deeper. It could be in your training data, it could be in your model architecture, and it could be in the model's behavior as well, right? So every model must be scanned to ensure it is safe, it is secure, it's cleaner before you deploy it to your production environment, right? And when you're talking about the spot management or the how these models supply chain risk or where these applications are deployed, then you need to make sure that you're able to continuously monitor and remediate your security posture where these infrastructure is run, right? You want to make sure that your apps do not have excessive permissions. It is not exposing any kind of sensitive data. What are the different kinds of governance policies that you have in place? And what are the access misconfigurations that are there in your cloud environment where these models and applications are running, right? So that will be the focus of the security posture management or the AI SPM piece. The third pillar is the AI red teaming. The way that we'll do this red teaming is you simulate an AI attack. It's an automated penetration testing tool for your AI apps and agents. So this you can integrate it as part of your CI/CD pipeline or the MLOps pipeline. And before you deploy your applications to your production environment or whenever it goes through a change, you invoke this AI red teaming agent. It does an automated testing. It simulates the AI attack. It carries out a set of attacks designed to override your system guardrails. Right? And based on the test results that it learns, the agent learns, it adapts to build better attacks. It carries out new attacks on your AI applications. So, this continuous learning and this feedback mechanism makes the agent more reliable and it's more effective, right? And you also get a detailed report outlining which attacks were successful and what sensitive information we were able to extract, where are the security gaps, or where you should focus to harden your apps and agents. Right? And that will be the focus of the red teaming. The fourth pillar is the runtime security. So, in order to protect your LLM powered apps and agents, we need to focus on the threats that occur at runtime. Right? So, we saw a few of them. It could be prompt injection, malicious code execution, and safety filters where you don't want your applications to be generating any kind of toxic content, or you want to make sure that responses that your LLM provides are grounded in your source truth. Right? You don't want any kind of sensitive data to be leaked. And memory manipulation attacks or tool misuse. So these are runtime related threats, and we'll be deploying runtime security to secure your AI apps and models from these kinds of threats. Right? And when we talk about the runtime security, we have two options. One is either you could deploy it as a network firewall where you would look into all network traffic, every transaction that goes between your AI apps and your models, or it could be anywhere. It could be your internet, it could be your internal applications. Everything is monitored, right? And you deploy it as a firewall form factor. If you're familiar with our current VM series and CN series solution, it is you can think of it as like a Swiss Army knife. So it can do everything our VM series and CN series do today in terms of securing your cloud landscape or even your on-prem infrastructure from traditional security threats, and it's augmented to secure your AI threats from AI threats as well. Right, so it's just a one solution, and you deploy it, but you get a comprehensive coverage, including your traditional security posture. And the runtime security also has a developer-centric approach where you could deploy this in your application code itself. So we give you an API key, expose an API endpoint, and you have to modify your application code and just make API calls. And this has much more flexibility where you would be able to define your own custom behaviors based on the verdict or the threats that we have identified. And the runtime security API form factor can be consumed in other fashion as well. So we have an SDK. You could integrate this as part of an SDK or consume this as a REST API endpoint. Or if you're building AI agents, then you could consume this as part of a MCP server as well. So today we have released an open source MCP server version, and we have plans to release it as a hosted MCP server too. So you can consume it in many different ways to secure your applications. Right? And the final pillar of the Prisma AIRS platform is the AI agents. So these agents have the ability to remember, plan, execute, and on your behalf. Right? So we'll be able to discover all your agents that are deployed in your environment, be it low code, no code, or pro code, and secure from agentic related threats, which could be memory poisoning, tool misuse, or hallucination attacks. Right? So in summary, we provide the best-in-class AI security platform. We have, for runtime, we can identify more than 30 different kinds of prompt injection in multiple languages. And then we also provide safety filters to secure yourself from any kind of toxic content generation. You have custom topic guardrails where you can make sure that your AI is not talking anything which you don't want it to. Right? And for data protections, you can use our out of the box predefined DLP profiles, or based on your organization needs, you can define custom DLP policies as well. And for agent protection, again, we can secure from memory manipulation, tool misuse in any kind of low code, no code, pro code environment. So before we dive into the demo, are there any questions?
Oh, yeah. Actually, we had several more questions pop up, which is great. One of the questions is, so we use the Prisma AIRS agent app instead of the AI app, that is ChatGPT. Is that the case?
So Prisma AIRS is to secure your homegrown AI applications, right? So let's just say you are building a customer service AI app or an agent, right? And you're hosting it in your on-prem or in your cloud environment. You want to make sure that you are protected, or your application is protected from threats like prompt injection, threats like sensitive data leakage, right? So you would still be using your own models, your OpenAI models, or it could be Gemini models. But you will deploy our security where we intercept the traffic before it reaches your LLM and apply security policies.
So Prisma AIRS isn't actually replacing the ChatGPT or whatever your custom ChatGPT is. It's just the protection for it.
That's right. Yes.
Cool. Okay. Next question is, for remediations to work, are there any specific permissions required?
Yes, you would be, because we will be deploying, let's just say we are deploying a firewall in your environment, right? So we need to have the relevant or required permissions to deploy your firewall, do some configuration, or even to do discovery. We need to be able to read your VPC flow logs, for example, right? So yes, there are some permissions required depending on whether it is discovery, where you'll be discovering your entire AI assets, or whether it's a deployment where we'll be deploying some kind of protection in your environment to secure this.
Fantastic. The last question we have at the moment then is this solution a different license or add-on, or does it come with Prisma Access Core license?
So this is licensed through software firewall flex credits, the same licensing model that we use today for VM series and CN series. So it is not the Prisma Access.
And then we just had one more person ask quickly, does AIRS, AIRS, stand for something?
Uh, it's not, it just airs. But I have seen people coming up with their own expansion for the airs. But no, officially it's just simply airs.
Me, I was actually thinking about that myself the other day. I thought it was AI runtime security. That was my guess, but yeah.
So runtime is just focusing only on the runtime aspect, right? But the Prisma AIRS platform, it focuses beyond runtime. So model scanning, agent security, posture, and things like that. But yeah.
Cool. Okay. Cool. Yeah, that's it with the questions for now. So please feel free to continue with the demo. Thank you.
Right. Just gonna stop sharing and then.
And while she's getting that going, everyone, the questions are coming in. They're great. Please go ahead and keep the questions coming. That's what we're here for today.
All right. Okay. Able to see my screen now?
Yep, you're good.
So what we'll do today now is just to give you a quick overview of our a demo of our platform. It starts with how all of these different pillars comes together and how it would manifest in our management console, which is the Strata Cloud Manager. So initially, the first step is onboarding your cloud account or wherever your AI workloads are run, right? So we support all three major public clouds, AWS, GCP, and Azure, and you could deploy the firewall form factor in your on-prem environment as well, be it KVM or ESXi, and even for different kinds of container orchestration platform, Rancher, OpenShift, and things like that, right? So today we'll see how onboarding would look like in a cloud environment, AWS, and what are the things that we discover in terms of posture, in terms of runtime, and how you can deploy security for that. So the first step is onboarding your cloud account. You provide information about your cloud account. Let's just say, for example, in here, your account name, the account ID, if it's the tenant and subscription ID, if it is Azure, for GCP, it's the project ID, right? And as part of the discovery, we need only read-only permissions into your cloud account for us to be able to access your APIs to pull information about your cloud asset itself, right? And these logs are stored in an S3 bucket, and you provide information of that S3 bucket here. And you can define what are the different types of workloads that you want to monitor and protect as well. So we can discover and secure all different kinds of workloads, be it virtual machines or container form factor or even serverless workloads, right? And if you're building your AI agents using any of these cloud native platforms, like for example, AWS, you can use AWS Bedrock to build your AI agents. And if it's in GCP, you can use the Vertex to build and deploy your AI agents. So we can discover the AI agents that are deployed in your cloud environment as well. So you can select if you want to do a discovery of the agents deployed in these platforms. And once you provide this information, the next step is we give you a Terraform. So what does this Terraform have? This Terraform has read-only permissions. We are not making any changes to your deployment or your cloud environment at this point. All we are doing is just accessing your logs, reading your APIs so that we can do a discovery of your environment. And so you download the Terraform, execute it, and once you execute it, soon we'll be able to start discovering your entire cloud ecosystem, right? So we'll be able to discover what are all the applications that are deployed in your environment. The discovery is not limited only to the AI applications. We can discover your non-AI application as well. So your traditional workloads that you're running, either on an EC2 instance or on your containers or serverless, in addition to the AI workloads too. So we'll discover what are the applications that are deployed in your environment, what are the agents that are deployed, and where these, sorry, just I have some pop-up. Okay. where these agents are deployed and what are the different models that these applications and agents are accessing, right? And if they're accessing different kinds of data sets, and who are the users who are interacting with these applications, and what are the internet destination these apps are talking with, right? So you give complete visibility into your entire ecosystem, not just limited only to AI related. So once we are able to discover, then the first step is here, so you can see here, we have two kinds of threats. We have identified some posture related stuff, and we have identified some runtime related threats. So let's look at what are the different kinds of posture related threats that we have identified here, right? So in here, on the right side, you see the actions pane, right? In here, we see some two notifications. The first, it says, okay, there are some models that are discovered in your environment. We have identified 12 models, 10 of them are already scanned, but we identified some two new models that are discovered in your environment. One is from Hugging Face, and the other model is from AWS Model Garden as well. And who are the users or the applications that are using these models, where it is being used, all of that information is available on the right-hand side, right? And in this unscanned models, the first thing is, okay, we need to scan the models. This is a threat. You have to use only scanned models which are approved for use in your environment. So let's just start a scan of these models, right? So once you start a scan, so you can see here, the model scan is in progress and it completed now. And we have identified that there is the Hugging Face model actually has some deserialization threats identified in it. So our recommended action, because this model is identified as malicious, is to block this from use, right? And with single click, you'd be able to block this. So we deploy the right policies where your developers who are deploying these apps won't be able to have access to this malicious model in your environment. So now we have only the AWS model, that the other model that was unscanned seemed to be safe. So it moved into, from red, it moved to green. Right? So now we have resolved one of the posture related threats, that is using a scanned and safe model in your environment. We still have one more threat where we see that it says a leads agent has excessive permission into Salesforce. Right? Let's look at that. So the view that you see here is all the agents that we have discovered in your environment, right? It could be a enterprise agents or SaaS agents, and leads agent is one of the agent. You can see that it also has access, or it is a main agent. It has sub agents as well, and this agent has access to the Salesforce application. And the Salesforce application, you have full admin access, including access to update and delete these records. So based on our analysis, we think that this agent has excessive permission. Right? Maybe it is legitimate, it needs it access to complete this operation, or it does have some oversight and it has been given excessive permission. It actually doesn't need these excessive permission to complete its action. Right? So as a user, you would be able to identify, okay, what are the different kinds of governance policy that you have and what are the violations, and you'll be able to fix this. So now we have revoked access for this leads agent, the update and delete permission, and it is given only limited set of access to complete its task. So this is the posture related risk that we have identified and resolved. Now we also see some runtime related risk. Right? So now we switch to the runtime tab, and here we can see that we see two runtime threats. Let's look at that. The first runtime risk, it says there are some agents that are deployed without red teaming simulation in place. Right? You have deployed some application and agent in your production environment, but it has not undergone any red team simulations. Now we have started the simulation. It's automated red teaming agent now does, it simulates AI attacks. It learns from the responses that your apps are providing, and it becomes efficient. It also gives you a report at the end. Right? Now let's take a look at the report. This report basically says that we have identified these kinds of different kinds of threats. There is some adversarial data exposure. There are some kind of prompt injection attacks. And okay, now we have identified all these attacks based on our red team agent. What are the next steps, right? The next steps are to deploy security to protect against these kinds of AI related threats. So, what is our recommended action? Our recommended action is we have two options. Either you deploy the network intercept, which is nothing but network inline device. Think of it as a firewall, which a traditional firewall, but it's augmented to look for AI specific threats as well. Right? Or you could deploy the runtime API, which is an API form factor. You would embed this in your AI, in your application code, and modify your application logic to take action based on the verdict that we have given. So when you click deploy its protection, now it's going to deploy this, whatever the form factor that you have chosen. And now if it's network form factor, then all traffic from your VPCs would now be redirected to the firewall, the network intercept device for inspection, and all the configuration will be updated, right? If it is API, then you would be making the API, embedding the API in your application code. We give you an API key, we give you a configuration object, which is the profile name to use in your application. And now we have resolved all the threats, both posture related threats and runtime related threats in your environment. And once these protections are deployed, this is the view that you would see. So you can see all the applications and agents turn green. We have deployed 4 firewalls and 2 API form factor. And these are the different threats that we have identified in your environment, broken down by category and severity. So this is how a typical experience would look like.
Cool. We had a question come in that they're wondering if the AI model scanning for malicious models and embeddings, if it happens within the user's cloud account, or does Palo pull it and perform the scanning within Palo Alto Network's own cloud account?
So what happens is the model files are, if you're bringing in your own models, then you provide us or upload the model files, and the scanning happens in our Palo's environment. Right? It doesn't happen on the user's cloud account. If you provide us the Hugging Face link or any other model hosting provider's link, then we download the model directly to our environment, and we scan and we give you the results.
Cool. Thank you. Another question just popped in of, is the visibility real time, or does the scanning take some time?
It is real time. There are also, because we rely on the ingestion of the logs that the cloud service provider provides, there are some SLAs. GCP provides it pulls log, or it pushes logs to the bucket only at an hourly mark, right? But in AWS and Azure, it operates differently. So at the end of the day, it would depend on the cloud's SLAs as well. But most often, in terms of discovering the application workloads and things like that, it is real time. Right?
Fantastic. Thank you.
Right. Any other questions?
No, we are good at the moment. Go ahead.
All right. So that's the end of the demo today. Hope you all had good overview of Prisma AIRS and what it does, what it's capable of doing. And I hope that you enjoyed the session.
Fantastic. Thank you. Yeah. If anyone has any last minute questions to go ahead and get in, now's the time. We'll have Usha here for another moment or two. But it looks like we might have had the last of the questions come in. So Usha, I do want to say thank you very much. Really appreciate the presentation today. I know I learned a lot. I'm still very new to the AI world, and it's terrifying the number of things that are out there, and the ways, it's just more and more ways that threat actors can go ahead and get at us. So yeah, thank you very much for that. Really appreciate it.
Yeah, thanks, Charles.
Okay.